Now, if any of you are after a list of specific tools, recommended tools, I'm not putting that in this talk. That story I shared with you at the beginning, those tools that we use to solve that problem, I don't use any of those today. Tools come and tools go. There's always a new trend, a new fad in a year or two's time. So what I want to do is give you a basis for evaluating tools yourself and making your own decisions about what's going to suit you, your organisation and your circumstances, rather than say use this tool and in 6 months' time no one's using it because it's become obsolete and replaced. Sound all right? Excellent. So let's look at development. So what automation do you think we could use to make development faster? And by development I mean actually writing code. That's what I mean.
Do you mean like Emmet?
Sorry?
Do you mean like Emmet where you can tap it?
Emmet's a good one. Yeah. So are you all familiar with Emmet? A mixture. So Emmet's, if I remember rightly, it's a plugin you can get from most editors and browsers, editors and IDEs these days. And what you can do is you can type HTML structures in shorthand and it will expand them for you to save you having to type all the tags out manually. Will that be fair? Yeah. So Emmet's a good one. What else could we use to speed up writing code? What do you use that you may not have realised is a form of automation?
Outsource it.
Outsource it. Okay.
Shortcuts to generate boilerplate.
Sorry, boilerplate code. So like skeleton generators, that sort of thing.
I've got this variable I need to get.
Okay. Getter, yeah, so adding getters and setters, that sort of thing. Okay, yeah, that's a good one.
Using an IDE that will like it sorts out the imports and namespace.
Okay, yeah. Yeah. So it's an IDE there to save you typing that kind of boilerplate text. That's a very good one.
Auto-completing based on...
Auto-completion. So code, yeah, code completion.
Like site generators, like Hugo, Jekyll.
Yeah. I would argue against things like Jekyll because you've still got to write a template to feed into it to start off with. So that's more of I'd say that's more of a static site generator than a code generator, I'd argue. But yeah, we're probably arguing semantics. Yeah. So the three, is it three? I think it's three. I went for code completion. I think is the obvious one. Especially because if you do follow me on Twitter, you'll see me swearing about this a lot. I use tools that don't have very good code completion, and it does drive me nuts. Refactoring tools, being able to move code around, rename it, and the IDE will go through and change all the references to it throughout your code base. That's another one you can look for. And again, IDEs offer that. That's a bit of a mixed bag, because if you've got something rewriting your code for you, excuse me, you may accidentally miss something important while you're doing the refactoring. So I prefer to do my refactoring by hand. I want to see what the consequences are of my change. I don't want to blindly assume it'll all be okay. Oh, what a soundtrack. I'm curious to see how the microphone picks that up. One I don't think I heard is code formatting. Are you all familiar with PSR2? Yeah. So for those who aren't, PSR2 is a layout standard for PHP code. It's not a quality standard, it's just a code formatting standard. I think there's at best 3 things in there that will prevent bugs if you're lucky. Most of the things in there cause bugs, but I'm going to get into that later on in the talk. But code formatting, and obviously you've got a language like Python where you've got no choice. You have to format the code or it won't run. Those are things as well. And they're normally supported by your IDE or your text editor of choice, except for the ones I choose. Now, code generation is one. You've talked about Emmet. That's a form of code generation. You've talked about generating getters and setters. Laravel users in the room? Yeah. So Artisan? Yeah. It will generate skeletons for you. It will generate templates for you. So you're just filling out those files. You're not creating them completely from scratch. You also mentioned earlier about actually doing the use statements at the top as well. That's another good one. Some frameworks will also give you tools to automatically upgrade your code when new versions of the framework come out. Zend Expressive, which is what I use, does that, for example. I imagine Laravel does as well. I'm not a Laravel user, so I don't know. I can't speak for that. But those are examples there of some simple things that will help us write code faster. Can you think of any I've missed? And I haven't come up yet in the discussion before we move on to integration. No? So how many of you use IDEs that have these kind of features built in? Okay, most of you. I'm going to throw a guess out here. Most of you PHP Storm users? Yeah? Anyone using something different?
VS Code.
Okay, VS Code?
No.
Yeah, VS Code. Any Sublime Text users in the room?
Yeah.
Excellent. It's nice to have you in good company. Yeah. Are any Notepad users in the room? No? I'm glad to see that development automation tools have at least reached the point where we're starting to use them all the time, and we're not using things like Notepad anymore. That's a good progress for the industry. So integration then. What do you think I mean by integration, or what does it mean to you? Code integration specifically is what I'm talking about. Anybody? It's not a trick question, and there's no wrong answer. It just works. Okay.
Is it just like making sure it works in its environment?
Making sure it works in its environment. Okay.
Version control could do that.
Version control does come into that, very much so. I assume you're all using some form of version control. Probably all using Git by now, I would hope. Anybody using anything else? It's willing to admit it? No.
Still some SVN.
Still some Subversion. In fairness, Subversion served us well for many years when we had no other viable alternative. So it is time it died, I would argue. So my definition of integration is, because hopefully most of you are working in teams and you've got some sort of branch that you're promoting your code into from where you're working. And integration is that merge. It's like you merging your code in with everybody else's. And if you're in a team that's very ticket driven, that might be the end of your involvement in that work. That might be how you deliver as a developer. In larger organizations, that's quite common. So you're adding your work to everyone else's, and you're making sure you haven't made things worse in the process, which can and does happen. And it's not a perfect process, software development. It never has been, never will be. So do you all recognize that kind of activity from what you do and your experience? Hopefully good. So how do you think automation can help us? Help us make that quicker? Because it's something we have to do as developers. It's something we have to be involved in. So how can automation speed that up?
So that's things like Git hooks.
Git hooks? Okay. Yeah. Yeah, we're going to come back to that one. That's a good one. So
Doing more often.
I'm sorry?
Doing more often.
Do it more often. We're going to come back to that. It's also a good one. Integration tests. Yep. I'm going to cover integration tests in a separate section later on. How many of you are using a CI server or CI service like Jenkins or Circle CI or Bamboo or GitLab's built-in system? Not many. I don't know whether you're lucky or not, to be honest. Anyone who's used Jenkins for PHP work will know what a frustration it can be at times, because it's not designed for our language. It's designed explicitly for Java and its properties. But if you're not using some sort of continuous integration service or server, strongly recommend you look at it, so that it is automating the testing that needs to happen when you've got a merge request or a pull request merged. So, do you do code reviews in your companies and organizations? So when you're doing a code review, what kind of things are you looking for? If you're the reviewer, what are you looking for when you're reviewing that merge request, that pull request? Anybody?
Sensitive tickets, it keeps to standards.
Okay. Very good. Anyone else?
Whether it works.
Whether it works, yeah. It's very important.
Whether it does what it's meant to.
I'm sorry?
Whether it actually works and does what it was
What-
specified.
So whether it meets the spec as well. Okay, that's an excellent one. We'll come back to those, both of those points. They're really good. What about down the back? What do you do in your code reviews?
Run the unit test suite.
Run the unit test suite. Okay. Are any of you collecting code metrics at all? No. One or two. We'll come back to that then in a moment. So the first thing about a CI server, and coming back again to my opening story about why I got interested in automation, is it proves you can build the damn thing on someone else's machine. It helps you avoid that problem where the developer goes, it works on my machine when you've got a bug in production, yeah? Of course, the standard answer to that is back up your email, we'll put your laptop into production when developers give you that. But a CI server helps with that. It helps to capture some of the problems where a build is done on a developer's machine and there's extra things lying around that have been forgotten about for committing to Git, or like the composer file references packages that can't be downloaded anymore because they've disappeared, for example, and packages do disappear. So a CI server, the first thing it does is it actually rebuilds that code from your source code. It does a checkout and it builds it. Now, I mentioned Jenkins earlier. Anyone who does use Jenkins will know that one of the problems with Jenkins is it actually keeps the environment after it's been built and reuses it from test after test, which means, like a developer's machine, cruft can occur in there and it can look like it's working when it's not. So it's something to be careful of. Someone shouted out about unit tests. And that's something, yeah, unit tests are boring. Let's get them run out of the way. And all a CI server can do is tell you whether it's a pass or a fail. It can't tell you whether the tests are worth a damn. It can't tell you whether the developer's gone and accidentally deleted a bunch of tests that are important. It can't do any of that. All it can do is tell you pass and fail. I mentioned code metrics. There is a long history in computer science and software engineering, going back decades, of running parsers over software and turning it into numbers. And saying, yeah, the most famous one would be, for us, would be PHP Unix crap index. Hopefully you've all seen that. Okay, so when you do code coverage in PHP Unit, and then you look at the report that comes out afterwards, the column, I believe it's on the far right-hand side, it's called the crap index. I can't remember what crap stands for. It was invented by a couple of people who used to work for Google many years ago. But it's a number that's calculated from the state of your code at the time. That's what it is. And there's lots of tools out there that do that. And I've got a story about those in a moment. How many of you do static code analysis? This is a new trend that's been coming around recently. I believe PHP Storm has one built in. I think they're using something called PHP Stan, but I could be wrong because I'm not a PHP Storm user. Exacat is an external service. Scrutinizer, which is what I use as an external service. And what these do is they look at your code without actually running it, and they're looking for constructs in your code that are dangerous. So they're not doing like code traces to understand if you've got paths that have got security problems or anything like that. They're looking at quite isolated things. But computers are very good at looking at things that we as developers don't clock in our heads when we read it. We tend to gloss over things when we read code, whereas the computer is much better at it than that. So if you don't use any static code analyzers at the minute, I do recommend going and looking at those. Certainly I'm very happy with the ones I use. But how many of these actually help us deliver quicker? They're all things we have to do. I'm not saying we shouldn't be doing that, but if we look at the list, do they all help us deliver things quicker? Do you think? Not always. Sounds like there's a story there. Okay. Care to elaborate?
It was purely just like we've had bugs in production once and then we've waited for everything to pass.
Right.
You know, you fixed like the line that was broken in question, yet you're still going to wait for everything to pass before you can actually hit deploy.
Yep.
So it only meant like it was an extra 10 minutes before we actually got the fix out.
Yep.
On the system.
Okay.
I've seen the situation where the process of building and doing a task is so slow.
Yeah.
What's actually happening is just being ignored anyway, so harvest will be done. Might as well just not be done and then sped it off anyway, so
Okay.
some of it's just pointless.
Yep. Speed is a problem with this stuff. There's no two ways about it. And if you're using a CI server to centralize running all this stuff, it becomes a bottleneck. In my experience, firms are reluctant to spend money on infrastructure to run CI to meet demand. It's an odd thing. You'll have developers sat around and can't work because they're waiting for the CI server, but they won't spend the extra money to spin up more boxes to actually run the CI server. So it's something to be careful of. It becomes a bottleneck. And it becomes everybody's bottleneck if everyone's going through the same CI server. Hopefully you're all fans of XKCD. This is one of their famous comments. Yeah. And if we change compiling for integrating or waiting for CI, that happens very regularly, especially in larger teams and larger organizations. So it's something to be careful of. Now, we can't get rid of this stuff. We need this information. We need to know the unit test pass. We need to know that the software can build, because otherwise we're shipping something that we'll never be able to get back and be able to do fixes on ever again. The metrics I've got a story about, and the analyzers can stop us shipping bugs. So we need all this stuff. But earlier on I said there'd be a running theme about a behavior, about trying to catch this stuff as early as possible. Now, one way you can reduce the load on your CI box is to actually do most of this work and catch the problems on your dev box instead. So at least when it goes up to the CI box, it's only going to go through it once. You're not bouncing back between CI developer in a long loop. And at that point, you might as well be out in the corridor jousting all day long. I have done that. I have been there. And I mentioned Git earlier because Git isn't just a faster, more convenient source control system. Because of the fundamental way in how it works, it's decentralized, it means that it makes it, doing integration is much easier on your machine every single day. It makes it much easier. Every morning you can come in, download the latest changes everyone else has made to the develop branch or master branch, wherever you're all pooling your commits when you merge. And merge them in. So if it's going to break your stuff, find out and fix it the first thing that morning before you move on to actually writing more code. And keep doing that. And the other thing you can do with Git is, of course, I would always urge you to use feature branches, but there again, I'm the maintainer of the Hubflow extension for Git. So you've kind of got a vested interest, you could argue. But the nice thing about working in feature branches is when a task is complete, you can nuke the branch entirely and start a feature in a brand new branch. So you're already starting from a position of already having integrated. So it helps reduce this cruft that gets in the way. Now, as well as Git, Docker is also changing software development. It's another paradigm shift. Because one of the problems we had when we tried to do integration in the 90s on our workstations, the results were unreliable. That's why we introduced things like CI servers, to get away from the fact that our dev boxes were full of cruft. But with Docker, we can spin up an isolated environment in seconds, and you can run it on very modest hardware, and even at scale. I've run a software billing system that was taking £100 million a year, and I ran that on an Ultrabook in order to do integration testing. It was a big system. I could run it all on an Ultrabook because Docker gets rid of all the overhead of VirtualBox and other virtual machine systems. So it allows us to have that automated environment that we need to know that integration tests and the results are reliable. And I'll say a bit more about that towards the end of the talk at this time. One more thing about slow. Whilst our laptops in some ways are faster than servers, especially cloud-based servers, if it's slow on your CI system, it's not going to be magically faster on your dev workstation or your laptop. So you have got to go and cut out all the stuff that's getting in the way. If your unit tests are taking forever to run, find out why and fix them. Maybe the app needs breaking up and you need to put some stuff in separate modules that can be tested separately to reduce the amount of tests you've got to run in one go, for example. But very important. For those of you in leadership and management positions, if you're not doing daily integration, your developers aren't doing daily integration, I would urge you to make sure that you can do that and that it happens. Because another thing I've seen with CI boxes, etc., is people are forced to do everything on the CI box. The bottleneck is forced because people in leadership and management positions don't lead their staff, they don't trust them, they don't train them. They use technology to try and force a behaviour instead. And after 25 years, I am very happy to say I have never seen that work out. Not once. It will get you some short-term gain, where all your good people will leave and you'll be left with the ones you wish you didn't have. So don't use technology, don't use CI to fix people's problems. Establish good practices, train your friends, train your colleagues, train your reports, so that everyone's doing things in a sensible way. And that way, when it hits the CI box, it's only going to hit it hopefully once and go through. And services like Jenkins actually have a bit of a gamification system to help with that. Anyone who's used a CI server will notice there's normally some sort of weather indicator or a traffic light indicator to say what the general trend is for that particular project, whether the builds are passing as a general rule or failing as a general rule. It's a little bit of gamification they've introduced. And you want really the CI box just to be sort of almost blessing the code rather than catching problems. It's what you really want. If your CI box is your first line of defense, things are going to be really slow. So I've got a second story then. I mentioned about code metrics. So a few years ago, I was in a position where I was observing several teams. One of these teams was using, all the teams had available to them a service that would do lots of code analysis and produce lots of metrics about code. Psychometric complexity, rate of churn, goodness knows how many numbers it was producing. But one of these teams took those metrics to heart very seriously, and they were constantly working with their code to make sure the code had better and better metrics as each release came on. And if it ever slipped backwards, they would put out a release to sort that out and keep moving the metrics up. Which sounds fantastic. It's not. The problem is when that code went to production, it failed. Not only did it failed so badly that the team was replaced completely on that particular program. Because the metrics don't measure how well the code does the job. They're not measurements in a scientific term. They're just a number. A measurement in a scientific term is normally a bounded range. I did a talk at PHP Northwest Conference 2016, 2015, I believe, where I've got a whole talk just on metrics versus measurements. They always video their talks. If you're interested in that, please go and watch it to see the difference. But the problem with these metrics is they're well-meaning, but they don't actually have any bearing on how well your code works. You can ship code that these metrics says is absolute garbage, and you can still get the job done and move on. Code does not have to be beautiful. It has to be fit for purpose. There's a big difference. I can see some shocked faces around the room. Does that sound controversial? Bearing in mind I actually run a QA practice, that's really what we do. At the end of the day, shipping code that works is more important than pristine code that doesn't work. At the end of the day, because pristine code that doesn't work doesn't pay the bills.